the afternoon. So good afternoon, everyone. So we have been through 3 sessions, and I was sitting here and finding out too many deja vu moments, like same things, same challenges, and I'll go over what we tried when we tried Nets in our product, integrating the ClickHouse database. Okay, so uh, this is about one of our product in the company, which is security, cyber security product. But I'll go over a little bit on evolution of the database technologies and how we reached what we are right now. It's the NetScout product with the ClickHouse database. Okay, so uh, myself, Ajit Bhat, I am engineering manager at NetScout Systems, and I have my colleague Afzal, who will deep dive into a little bit of technical nitty-gritties that we dealt with. Okay, so let's start. So this is the agenda. I'll start with the analytical foundation that we had as our company, what kind of data sets we are dealing with, and then the ClickHouse initiative, what prompted us to evaluate. Uh, I'll spend some time about how and why we evaluated ClickHouse, and then we'll go into design and implementation. Afzal will take you through performance benchmarks and some of the challenges and benefits with ClickHouse in our product. Okay, that is the agenda. So let me take you through the so NetScout is like it completed 40 years, and we were started as the network monitoring company. So if you might have heard about the ARMON2 standard of network monitoring, and so our founders actually are contributors of that RFC standard of ARMON2. So from there, monitoring the networks, conversations, and host and IP addresses. Uh, we were there when the IP network was establishing and the challenges of monitoring the networks, expanding the IP networks. So that's where we started network monitoring and analytics, application monitoring. Things were getting complicated in the networks and applications. And from there, parallelly, as our team, we started our database journey. So actually, we started with Sybase database when we were monitoring the Armon2 conversations, where like touching 1 million was like a victory in terms of database. Okay, so from there, then little bit of how the product deployment is. So this is little bit of difference than what you had seen the stories about cloud-based deployments and all. So this is how our customers deploy our products. Okay, I'll go from down. So these are like network equipments, our own hardware appliance boxes that customers deploy to monitor their networks, all the gigabit or 100 gig links and all that. That's what our probes monitor and create the conversations and IP data. And these are the servers, these are the, and all these are physical boxes. We have the virtual counterparts, but mostly like big service providers in the whole world, US or in India, Reliance Jio is our customer. So they all deal with high-end appliance boxes because they want all the data into their data centers and in the physical appliance boxes with lot of horsepower. Like HP or Dell, typical appliances are like 256 GB memory and about 92 CPUs. That's what these servers are. So multiple local servers collecting data from multiple network equipments or probes, and we have a super server which we call global server where the users log in, and basically you can imagine they see the data from all over this. Every server has its standby server for redundancy, and what we do is we sell the appliances and software as a bundled products. Customers can get their own boxes also, but this is what a little bit different than than the cloud offerings or virtual boxes. Everything can be virtual, but that's the rundown on how customers look at the data. Okay, So whenever I am talking about this, we are going to talk about data at this level, where local servers level. And I'll be talking only about the performance and whatever query and all at this level, where ingesting the data and the query performance. So it's scalable horizontally, but that is because of the deployment thing. We are more concentrated on the performance of a server. Okay, so this is a little bit of background. Then what we had before we evaluated the ClickHouse as a database. So this is the homegrown columnar database. That's what we ourselves wrote. Afzal was there by me for almost 15 years, but around 20 years of legacy of homegrown database. We rewrote and improved it twice within 20 years. Then we had PostgreSQL, which especially used for inserting and retrieving the security events. So security event side data, we use Postgres. Then on the top of columnar database, we had custom index framework. So separate indexing framework, searching for presence and the actual typical index functionality. And write statistics, these are for the local server, basically. 100 million network records. This is about the conversation and TCP IP details and all of the enterprises IP addresses that we look at. And 100,000 security events that are being inserted every 5 minutes. All this is 5 minutes. So it's like time series data. Every 5 minutes we collect the records and insert into database. And the internal replication of redundant servers, if you see the redundancy servers are there, that is also homegrown, we manage, because nobody can do the replication of our own proprietary data. So we had the replication of redundant servers also. Okay, so this is the legacy data stack that now when coming to ClickHouse, what were the challenges and how we solved it. Okay, but to qualify something like, okay, how good is ClickHouse? So this was the scale of the data that we already had. Okay, so 100 million records we were inserting every 5 minutes into the local server, coming in from many network devices. Okay, it started from 500K to 3 million, and now this is the benchmark we had before going into ClickHouse. 1 million records per second was the ingestion rate we were able to achieve, and what that translates is like 450 billion rows of data in the database. And just like any other, like you mentioned, we have to return the data on the dashboards. So a lot of pre-aggregation roll-ups warehouses. So that becomes another 200 billion rows in the database. So this is the structure or kind of data we had, and we were looking to match, at least we want this much, and this is on the single appliance box. Okay. Now why we started looking at this is we had a lot of data, we had very good ingestion, but the problem started cropping up is the latency of the queries, responsiveness. And why this was not a problem before? Because this especially we saw in the security product. Okay, in the network products where the network teams are looking at only a small part of the network. So they don't want like whole enterprise view. So nobody is looking at like 100 million rows of data. They are looking at small sets. So they did not have challenge, or the products were developed in such a way. Now we had an enterprise view where all 100 million rows might need to be mined, and we have challenge of the latency. The enterprise queries were very slow. So our users also, in the security product, our users are analysts. So they are not network administrators who know, like one thing I know, when we built the search framework, one service provider in Germany, he wanted to search a host IP address in their enterprise. And our search used to take like 10 minutes. Okay, but he was okay. I found it on the customer call. He was okay with it because he will start a search, go for a copy, and come back. And why? Because there was nothing else that can give you. He's okay with 10 minutes. So that now those are not our users. Our users are security analysts. And beyond 10 seconds, if you can't show something, then it's unusable product, right? So that's the challenge. Then with the security data, basically all data is still network TCP/IP, but on top of it, the security analytics came in, and lot of string data is there. Third-party security databases, integrations, and you have string data that people want to now store. And our homegrown columnar database was not good for string data. We used to, in fact, we used to drive away people who wanted to store strings before. No, this is not a place for you. Okay, and user experience is actually all of these culminations. Another one that actually we were not thinking this is a problem, but customers were having it, is the database sizing. Like one benchmark, you say 100 million, beyond 100 million, somebody goes, we say, okay, buy a new server. And the server's disk requirements were very high. Actually, we had more than that in the network equipments where they store all the packets, all the packet data. So, but they understand that, okay, packet data is a lot and they need this. But what we are showing is the user experience and statistics data, and you still need that much of data disk. So that was also becoming a concern of database sizing due to our own columnar database, which was like backed by flat files, just similar to ClickHouse, but not to this level of ClickHouse sophistication that we had. Okay, so this is what we started with implementing. So what we had for our columnar database to get up to that point, we had these things. Columnar, it was, we were using LZ4 compression, and we were getting good compression also. Real-time ingestion was there, horizontal scaling by means of servers, but the number one point was query response user experience, where we were struggling and we started the evaluation. Afzal will take this ahead. He will talk about evaluating and what all decisions we made. Many deja vus like previous presenters.
So like Ajit mentioned, we had our homegrown data set. So there were two versions of it and we tried, we finalized to go with ClickHouse. So before going with that, we had an evaluation period of taking top 20 queries of our existing product and then evaluating it against with ClickHouse. So in that frame, we started designing the databases. There were multiple roll-ups, warehouses existing into our system actually in the homegrown. So we compared that apple to apple query responses against ClickHouse. And what we found a 10x response time actually. So when we have the similar load on the old house and the new house, we can say it is a new house or a new data set with a new house. So with that, we saw better responses coming from ClickHouse tables, and that's when we decided, because we did not want to go into production and then later come back. So that's the reason we did that evaluation. After evaluation, we started designing the table. So as all suggested, we started with merge tree, but merge tree was not sufficient even because we wanted redundancies also and replications also. So that's the reason we wanted to replicated merge tree. And we also had caching, which as suggested that we wanted indexing also. So that's the reason for few tables we use the replicated replacing merge tree. And for the distribution, because like Ajit said, all the queries were coming through the global, so we use the distributed engine to span out, which cuts down the manual way, which we were doing initially was going to each server, taking all the data, aggregating it and giving it back on the global. So that cuts down here by using the distributed engine. Later on, we had, while designing the table, we decided on filtering what are the most common filters which are coming for every query. So we targeted target time, IPs and other things which are more prominent in every queries. So the designing was based on deciding what is proper ordering to be table set for, and also doing more denormalizations so that we cut down the use of lookups or joins. Doing that, what we achieve is more better responses. Also the partitions, because we want to age the data, we had decided it's a time series data, So we had target time as a partition. So that we introduce into the schema, and partitioning is done based on that, so that we can purge the daily partition. So we have like for every different tables, there are around 34 tables, which are raw tables, and then we have around totally 94 tables, which is like rolled up, warehoused, and other things. So the daily partition thing help in purging, because for every table we have a sequence of like when to purge those tables. So that we the partitioning helped in. And also the roll ups are warehouses. So why? Because it's a 5-minute time series data. The responses should not always come from the raw data. It should vary based on the user. So if the user is asking last 7 days data, it should come from a daily warehouse data. So similar way we have, so there is a lot of background data activity going on. So that's the reason we also the basic ingestion is for 5-minute data, but in the background there are a lot of activities which are happening, which is doing the roll-ups for hourly, daily, and based on the UI design or other requirement from the users. Coming to the ingestion, over here we did not use any standard JDBC implementation. We went with ClickHouse client to do the ingestions, and we dumped, because we had that we have to just remove our old data set and replace it with ClickHouse. So it was easier for us to dump those data set to CSV and then do the CSV import. So major of our data ingestion is done through CSVs. Here also we have to do a lot of trial and error, because initially we were inserting like 5 million rows, which was doing what was it doing is it was creating a lot of memory bubble into ClickHouse. Then we have to cut it down and come to a number. It's like for now we have a 100K chunk size for each CSVs. So like 100 million data sets are cut down to 100K chunks of sizes, and then they are ingested through multi-threading. So that is how we do the ingestions. The second way of real-time data ingestion, we use streaming, like ClickHouse pipe streaming. So there are two ways we do ingestion, one through CSV, one through pipes. We don't use any JDBC ingestion here. Then we were seeing some issues while write. So we use profiling, because as you see, our one system does everything. It has the data sets also, it has the applications also. So it is performing all the things together. And what tendency of ClickHouse we see is it hogs everything what is available. So we have to tone it down. So that's the reason we had profiles created, user profiles created. So we have write, read, and background process profile created, so that we can tone down the threading model for each profile, and then all the write ingestions are going through a write profile. So that's when the profiling came into picture, and we can tone down, because we don't want to ClickHouse to interfere into other processes. There are multiple different processes which are working all together in one local cell. Let's go to the okay. So why we do the warehouse? As I explained, we can't do all the, I mean, for the UI experience, better experiences, the it's up to the user to select the real-time 5-minute data set, or do a standard analysis where he goes to up to 1 month or 3 months data set. So based on that, we need more warehousing, more roll-ups. We also use materialized view in most of the cases where we have to automate roll-ups. Whenever there is any ingestion done, the roll-ups, the materialized view do the warehousing and roll-ups. So we also make use of materialized views. Purging, as I explained earlier, we use daily partitioning, and then daily purging is again a background activity which purges the data, and we have set limits for every table to purge at a particular time frame based on the user settings provided in the UI. This coming from the read part now. So here also we did not provide any JDBC interface to read the data. We use the ClickHouse client library, Java client library to read the data set. And to enable that, we used our own, again, homegrown standard framework, which is like a plugin based framework. So plugin based framework gives you control. We did not provide any normal SQL type interface where the user goes and pollutes or do any query, anything as such, which is not, what you can say, which can hamper the performance. So that's the way the interface to the DB is through the plugins. And why through the plugins? Because it gives you better control, and it also gives you optimization interface. So whenever there is any request coming from the UI, we have a better control, and that's the reason we had to put in here. We did not went to any standards frameworks available. We created our own framework, and now I think that's working pretty good. So here also the tuning part, as I said, the profiling we did, the profiling was based on uh, the number of threads we provide to the user. So here also we saw multiple users doing multiple queries at a single time, and then it's like slowing down the ClickHouse performance. So we had to tune it down. Tuning comes into picture there. The latest one, yeah, the latest. Okay, so this is the this is the implementation. Once we are done with the implementation, the local servers over here, they now have ClickHouse and the global servers. So the structure, why we wanted, because this was our federated architecture, and we wanted to implement the same architecture. We don't want to have a separate ClickHouse cluster outside. So that's the reason we have to make ClickHouse cluster work according to our federated architecture. And there we saw some, we managed to do that by having a single node, having per node on each local servers, and the global making the distributed call and getting all the data from every node. But in between, what we saw, there are issues when there is any local server, because there is redundancy. We saw that sometimes if any of the node is down, we see responsiveness issues coming because of the third party zookeeper which we are using to manage the redundancy. So that is one observation we had, but we were managed to handle this, and we are still working on verifying, or if we are thinking if there is any other way to handle that, like if there is any we have heard of ClickHouse Keeper also coming into picture. So there are a few queries which we want to what do you say, come up in this and ask whether putting this into a federated architecture is a better design, or having a separate cluster of ClickHouse will be good enough, or because we want to manage it. We already had a product which was into release, and then we are putting ClickHouse and asking them to continue with that. Okay. So what we achieved from this was, we had to go away from all the manual things which we are doing, like replicating the data manually by ClickHouse redundancy. We had to do that by managing the overall query responses from the global. We have to query all the local servers and getting it. So with distributed table design or engine, we can do that, we can achieve that. We have to go away with that. And by doing multiple streamline rollups, we achieved in getting better user response. So overall, the focus where we started was to give the better user response, because it's an analytical product that we achieve by what do you say, creating multiple rollups, designing it in certain way. And system tuning. So system tuning involved development. As I earlier said, the hogging issue which we saw, that ClickHouse used to hog all the resources. So there we tried to tune it down by using CPU set and assigning particular CPUs. Like if there are 96 CPUs, we used to assign 50% of the CPU set to the ClickHouse. So it would not go beyond that. So because it's a mixed environment, working in a mixed multiple application running on the same server, so ClickHouse used to hog everything, and the other application used to suffer it. So that's the way we use CPU sets and other tuning parameters to control it down. So there was something different. Yeah. Actually, this is not the PPT. It's a different one. Yeah. So basic, what we want to explain here is we were looking for some better user experience which we got from ClickHouse, but there are also few things which we want to work on, like the one which I explained, the Zookeeper. So we want to go away with that, and we need some suggestions from the ClickHouse team, how, I mean, whether that's how that can be done, or it can be put it in the existing architecture, the federated architecture which we have. So is that possibility? Also, few things which we saw, there are a lot of background activities, as I said, mostly roll-ups, analytics going on into the background, which causes a lot of noise, lot of merges, and that what that does is it slows down the system. So is there any, I mean, we are looking for more insights from the ClickHouse team, if they, that can be handled in certain way, or is there any thing coming up to resolve this?